program. No, without you need an introduction. Award-winning teacher and scholar who works on simplification. He's doing a targeted study of that right now, a major project. And somebody who's played an instrumental role in why we're all here, connecting and guilt-tripping us for not doing open source stuff. And so we are, and here we are all fanatically running around doing open source, and it's working out fantastic if we do. So Rich is going to explain to us what open source is all about, and why it's a wonderful thing, and he's a full professor of English, SDS, so all that, because that's last semester for that.
And information science technology.
Yeah, and information science and technology. So Professor Doyle, Rich, thank you so much.
Thank you, Professor Devin. I appreciate you guys listening. I'm open to multitasking that you're doing. I don't really want to interrupt what you're doing while talking about what you're doing. But I do enjoy coming to this class. This class sprouted out of a collaboration between Professor Devin, Dave St. John, myself, Eric was there, and all kind of in an unholy alliance, working under the aegis of the National Science Foundation to try to figure out how we might do a better job as a society preparing for technological change, right? So it almost sounds like an oxymoron, right? What's an oxymoron? Anybody know what an oxymoron is? Of course you do. Yeah.
Contradiction.
Yeah, it's a contradiction in terms like prepare for technological change. It's like, well, you can't. Well, we can do slightly better, right? Just like after people discovered that DDT in the environment works through the food chain. Everybody knows about that from the 1960s, DDT. Everybody know what DDT was? What was DDT in the back with the Argyle sweater? Yeah.
Is that an aerosol can, or is that the...
No, but that's cool. I like that association. No, it's good. Yes?
Insecticide?
Yeah, it was the insecticide that, if you see the borderline, I think beautiful but nearly unwatchable movie Tree of Life, so nobody saw it, you can see the kids running through the clouds of DDT in the street, and I can actually, I'm old enough to remember that, because the mosquito dude would come around with these, like trucks that would spray DDT in all directions, because it was controlling for mosquitoes. And of course that's a good thing, right? We don't have any malaria to speak of in the United States, but the downside to DDT entering into an ecosystem was seen to outweigh the upside of controlling for mosquitoes, since there were other ways of controlling for mosquitoes. So the idea has been in technology circles for at least 40, 50 years to try to get out in front of plausible opportunities and plausible challenges that any new technology presents. And we were trying to do that for nanotechnology, which is enormous, right? So how many people have heard of the singularity? Singularity. Too many people probably. You're like, shut up about the singularity already. It's in effect. Get a late pass. I kind of agree. I think when we're trying to imagine technological change, very often, as with other things, what we really see is what we wish to see, right? We see a certain version of ourselves. So when Raymond Kurzweil looks into the future, say 5 or 6 years ago, and sees all the massive, rapid technological change that's going on under the name of the singularity, which gets capitalized sometimes, it's like a crystal ball, right? And he sees himself. He sees himself living forever. And probably many of us, that when we imagine something in the future, what we're really doing is imagining what we want to see in the future. And so this is one of the keys to open source, because open source helps us hack through our own little individual fantasies about what it is that we want to do, right? And get over something that human beings have been kind of stuck on for a couple of 100 years, which is the individual ownership of knowledge, which I want to suggest to you is another oxymoron, right? Why is the individual ownership of knowledge, at least on the surface, a contradiction in terms? Sir?
Because in order to have knowledge, you have to have taught it to somebody else. So it's not something.
I didn't learn anything from anybody else. Right, no, exactly, right? It's like there was a cartoon by a biologist I really liked from the 1960s, this guy C.H. Waddington. And he has a picture of a chick coming out of an egg, like the that egg is still like on the chick's butt, you know, it's coming out. And the chick turns and looks at the egg and says, me come from that? Are you kidding? Right? Not having any of it, right? So this is what happens is we get knowledge from elsewhere. We learn from our teachers and we learn from each other. And then we say, oh, I had this great idea this morning, right? Which is bizarre. It's just like, whoa, how did we suddenly go first person on that? And it's understandable, right? Because for the past several hundred years, we need to survive as individuals, right? We don't get to survive as groups, right? We survive as individuals. But the beautiful thing about open source is that it returns us to the roots of science. And that's what I'm going to talk to you just a little bit about today. And suggest to you that what the singularity is really about is about the arrival of radically networked science. In other words, that some of the obstacles that have kept us from moving scientific and technological innovation into the world at a more rapid pace are overcome by network science. We're going to talk about that and why that's, there's very, very simple reasons for that. Because we leverage the fact, we use the fact that knowledge comes from other people. Now, I don't want to give you the wrong impression. And I don't want you to think that what I'm describing is some big Linux Borg where there is no individuality whatsoever. No, absolutely not. Because, sir, if I can refer to you again, when you learned from someone else, were you learning from them as a general anonymous individual? Or did an individual teacher or person talk to you as an individual?
I'm confused about what the first choice is.
Yeah. Well, yeah, because you've never met it, right? In other words, you couldn't learn from an impersonal, kind of faceless being, right? Even if you think Wikipedia is that, Wikipedia is created by individuals. The collective has to be made up of creative individuals for it to work. Yeah.
Are you referring to your imagination?
Well, your imagination is the place where we're both the most individual and the least individual at the same time, right? It's the most individual because only we can experience individually our imagination, right? But it's the least individual because when you imagine something, very often you're imagining things that human beings have been imagining since there have been human beings, right? So I think imagination is very much what we're talking about today. So the point is that individual creativity in a collective is what we're talking about, okay? So what's the history of those collectives? Because what we're really saying is, where does science come from, right? Where does science and engineering come from? You can say, well, it comes from money. We put money into context and we gather people as in a hive or something, and then we have them exchange money from each other. But you know what? It's kind of interesting how that doesn't work, actually. A very quick anecdote to illustrate this. A friend of mine was on a plane coming back from California, and I don't know what happened, but he ended up in first class somehow. Maybe there was a mistake. And he was sitting next to the person who is one of the founders of Sun Microsystems. Everybody's heard of Sun Microsystems, right? Indian guy. So my friend says, how long is it going to take for India to pass the United States in engineering and science and technology, right? And the CEO of Sun Microsystems says, 75 years. And my friend's like, why is it taking so long? You know, why? You know, you've got 1 billion people. You're undergoing singularity technological advancement at a rapid pace. And he says, you wouldn't believe it. He says, I have this company in California. People show up, they play Frisbee, they write code all day, they don't want to do anything else. It's a culture of creativity, right? So what we're talking about is that there's still a culture of creativity that's necessary to the generation of novel ideas and innovations. And that doesn't just come out of nowhere. People come all over the world for that. I'm not arguing that other cultures can't do it, but it's what we still have going on in the United States right now. And leveraging open source culture is going to help us. So where historically does science and technology come from? How old is science? Anybody have any ideas? Just off the top of your head. Isn't that kind of like it could be a science of science, right? How old is science? on the one hand, you could say it's, forever, right? Since a shaman in the upper Amazon started having visions. It's 6,000 years old. But most historians of science trace it to the Royal Society in England in the 17th century, because this is where clubs of people started to get together to share their research. Sound familiar? Now, the Royal Society was very interesting because they basically wrote up protocols that haunt you to this day. Why do they haunt you to this day? Because when you're writing up a technical report, you know how you're told not to say I or to use the first person? Yes? Right? And to use the passive voice as often as possible? Right? The experiment revealed, right? Rather than we learned, right? This is because the Royal Society made a taboo on including yourself in scientific reports. Right? In other words, if Boyle, anybody heard of Boyle, Robert Boyle, right, comes up with one of the first scientific laws, right, in modern times, he's making his air pump and he determines a law. But that law shouldn't have anything to do with Boyle, right? It shouldn't have to be Boyle at the pump, operating the pump. Although, by the way, in practice, it kind of did need to be Boyle at the pump. Because as you know from your rep raps, you can't always get the shite to work, right? You have to tweak it, you have to put a little duct tape on there, you have to make it work. Quick example on that one is personal computer. How old do you think the personal computer is?
50 years.
How many?
50? Oh, personal, sorry.
No, you're very close. It's 43 years ago was what was called the mother of all demos by Douglas Engelbart, who invented this thing right here, the mouse, right? And he had a demo. You can look it up on YouTube. It's a very interesting demo. He had a demo that was so amazing to people at the time, because remember, computers were big old mainframes. They weren't oriented to individual users. That many people assumed that it was a hoax, right? They thought that it was boxes with, that it couldn't possibly be real, that nobody could have come up with that. But a friend of mine wrote a book about Douglas Engelbart, interviewed Douglas Engelbart, and Engelbart said after the mother of all demos, he went and contacted some of his funders, which included the national security establishment, people like the CIA. And he said, look, I want to show you, what we've come up with here with this thing we're going to call, I think he was calling it a personal computer at that point, I'm not remembering. And they said, oh yeah, well, we've already seen that. And I said, well, how did you see it? It's like, well, we built a copy of it in Langley. Langley is where CIA is built. It is located. However, I asked my friend who wrote the biography of Engelbart, I said, did the computers in Langley work? And he said, no, nobody could figure out how to get them to work. So it's one thing to be able to replicate the prototype, and it's another thing to have the culture that actually makes it run. And that's what you're a part of here. So Royal Society was a culture of science. It was a way that gentlemen in England in the 17th century, yes, they excluded women at the time, got together and they competed. And they competed over who could come up with new knowledge, right? Just as maybe you compete a little bit about who can make their rep the most badass. Maybe, I don't know. And now, you might say, but why did they ban then individual creativity, or the marker of individual creativity, in the write-up of what they were doing? And you can say, well, they wanted it to be objective. But why? Well, the reason is because the year, about 30 years before, was actually the first scientific society, is this Academia Dea Secretorium Naturae, right? And they got together and shared information, mostly astronomical information. So for example, this Della Porta character argued that he was the first person to invent a telescope, in fact. So they were sharing ways of doing astronomy, they were sharing astronomical knowledge, and they were shut down. They were shut down because it was suspected, as it is to this day if you do science, that they were engaged in occult behavior, right? Because guess what? Nobody could understand what they were doing. People would read things by Della Porta and think that they were having traffic with the devil. So Royal Society comes out of this and they say, we're not going to make that mistake, okay? We're not going to be tried as witches. we are going to share transparently our information to as many people as possible and abstract it. Everybody know what it means to abstract something from a context? Like make it so that the context doesn't matter. And we've been enjoying the fruits of that for the past 400, 500 years, right? Now, one of the side effects of that is, however, that even though they got rid of the personal voice in scientific method, ownership remains, right? See that little bit of contradiction. That the idea that you can start owning and patenting knowledge starts to become an obstacle. Why is it an obstacle? I'm really only going to talk for about 5 more minutes. It's an obstacle because it starts to become difficult to bring all the sources of knowledge together. Because we only get knowledge because we learned it from somebody else. So if you come up with something that you can own, you've got it like Gollum, it's like the precious ring, my precious, right? You hide it away, right? And so I watched this happen with biotechnology. This is one of the reasons I got involved in nanotechnology, is that I watched this happen with biotechnology when in the 90s and even the late 80s, when people started to be able to sequence large amounts of genomic information, everybody said, like, I'm going to get that gene. I'm going to own that gene. Where a gene is a sequence of DNA that codes for a particular outcome. And you started to have Dave owning one gene, I was owning another gene, Professor Devin was owning a gene, you were owning a gene. And then we figure out that, in fact, it wasn't so simple as we thought it was. When genomics was first bootstrapping itself, a lot of people really thought that we were going to be able to go down in there in the genome and say, oh, look, it's that bit on your chromosome that is messing you up and making your hair look all crazy, right? We can fix that. We'll attach a new bit of DNA to a virus, throw it in there, you'll get infected with it, and voila, genetic therapy, right? But in fact, it's really rare that one gene causes anything. Instead of it being one gene causing things in your body, you are a massively parallel network, right? Where genes are turning on and off all the time. So the more the biologists start tracing things like diseases, the more they find that, oh, actually, okay, we found something significant, but it takes 7 genes. This gene has to be turned off when this one's on, and this gene has to be on when this one's off, and so on, right? On and off regulatory networks of genes. But now what happens? The company goes to Dave and says, hey, Dave, we want intellectual property rights on your gene so we can make this drug. It's like, okay, well, maybe we can talk. And then they go to Richard Devin and they say, hey, Richard Devin, we want this intellectual property rights on this gene. And pretty soon, you get to 7 people, and guess what? The lawyers are very happy because they get to carry out 7 different sets of negotiation, and they never come to a conclusion. There are many, many examples of drugs and technologies not being developed because the intellectual property was in the way, right? We watched in a class on nanotechnology as one of the researchers who came in gave a talk about coming up with a microfluidics technique for instantly and cheaply finding cholera in water, right? Cholera is nasty stuff, right? If you could know that it was in your water before you didn't drink it, that would be a good thing, right? Does it exist? No, it doesn't exist. Why doesn't it exist? Well, because it would only work, it would be something that would be used in the developing world, and developing world means less money than non-developing world, so why would we develop for that market? A. So no venture capitalist is going to back it. So then we say, well, hey, why don't we open source that thing, right? And make it so that anybody can develop it anywhere. But then you can't get venture capital backing for if you don't have intellectual property rights. So what we're trying to work out now, and what's getting worked out even the intellectual property office at Penn State, is that there have to be other ways besides owning intellectual property. And as you know, there's lots of ways to make money off of knowledge without owning it, right? IBM gave over $2 billion to Linux maybe 7 years ago now, and knew they were never going to own it. But they can make money off of Linux because they can sell the services of installing the software, dealing with the updates, doing with all the services, right? So today, New York Times, apropos of my talk today, and there's 2 minutes left, finally, because we've been raving about this for years, making it to the New York Times, that there's 2 stories today in the New York Times about open science. That's what you're engaged in, right? You're engaged in open science because if it wasn't for, who's the professor from at Bath, David? Adrian, we'll just call him Adrian. Yeah, sharing his vision, none of us would be here, right? We wouldn't be making these copies. And we're doing things that he could never have imagined with his work, right? So when your rep isn't working or you're wondering why it is you're bothering to, to do this, I don't know if that happens to you, or if you get depressed because you can't tinker it together, I want you to possibly remember that this dude came in and was raving about something, and that it was that we were about to hit some new threshold in our society of technological innovation, and that we're doing it because we're sharing the information rapidly, and that the things that we do as a collective intelligence dwarf what we can do as a collective of individuals, and that you're a part of that, and that's really very likely to revolutionize the planet in the next 10 years. And even the New York Times thinks so. So think about that when you realize that what you're participating in is a planetary revolution, technological revolution. This is a new thing. It's mundane. We're squirting plastic down into patterns, right? We're programming that plastic. But you're sharing knowledge, and with the sharing knowledge, you can rapidly proliferate the knowledge over the planet for open source yumminess and planetary transformation. Thank you for your patience.
Are you taking questions?
Yeah, of course.
Any questions? The science has always practiced the idea of sharing knowledge, practice open science. It's really engineers guilty and the other useful arts who've been guilty of property. The intellectual property. So I know that's a gross distinction, but to some extent that there's some truth. Okay.
Well, yeah, it's way more, like, for example, when Darwin was writing The Origin of Species, he could get, from the dog breeders, they'd give him all of their data, the farmers, the mechanics, and so forth. The gentlemen that he was interacting with in the Linnaean Society, they withheld a little bit more, like what they wanted to give and what they didn't want to give. But it didn't really get to be the obstacle that it is now until, in my view, post-World War II, when knowledge became capital, right? So the very interesting thing happened at UC Berkeley out in California a couple years ago, where there was this idea that they would get, I think it was Monsanto, to sponsor half of one of the biology departments, right? Why? Well, because they wanted the money, right? And then Monsanto would have intellectual property over some of the findings. And you can say, well, that's really not that different. National Science Foundation still funds most of it, and people do private research. What's the big deal? Well, the big deal was that people found that they stopped sharing their information, right? Colleagues would usually go out to lunch together and say, oh, what are you working on? Oh, I'm working on this. And then boom, you put it together. They stopped, right? And in fact, they became less productive by most measures during that period of time. So it really, I think, you're quite right, that it's a hiccup in the history of science. Science, in general, means shared knowledge. Over the past 50 or 60 years, it's been not shared as much. Yeah?
I was going to say, I was telling the class that when I first started, I used a software called Evernote. Have you ever heard of it?
Yeah.
Keep track of everything.
Yeah.
And I just started thinking of different like future designs for new technology and inventions, basically. Just using my imagination. And I tell people who are really close to me, like my mom and things like that, really close friends, and they always say don't tell anyone. But at the same time, it's I don't know who to talk to to actually have it happen. Because I want to tell people, because I'm coming up on 100.
You want it to happen, right?
Yeah, I want it to happen.
Well, so then you should share it as widely as possible. I mean, here's the thing: is that there's 2 schools of thought on it, right? We had a venture capitalist come in the class a couple years ago, and he was like, "Keep the notebook, don't let anybody else see the notebook," and so forth. And it is true that if you're an undergraduate, you own your intellectual property. Right? I hope everybody knows that. Not if you're a grad student or a faculty member, you got to make a deal with the university. But if you're an undergrad, you own it, right?
After 12 months, nobody can own it.
Sorry?
After 12 months, no one can own it.
That's
You
right.
can make it public and keep it public for 12 months without any.
Right. But if your goal is for it to happen, I really think the paradigm that's coming along is you get it out there and you're still going to benefit from it, right? Instead of trying to hold on to the knowledge, whereby probably that means somebody else will just do it, right? Because if you're having the idea, somebody else is probably having the idea. I would say, share that stuff. Except the really good stuff. No, no. If you share it, you're going to find collaborators, and if you find collaborators, it's much more likely that it's going to happen. And if it happens, then you're going to get some benefit from it, even as an individual, as opposed to just if you have an idea and then someday you're pissed off and you read the papers, somebody else came up with it. Other questions? No mas. Yes?
So do you believe that patents are actually what's holding back the scientific community as a whole?
It's obviously more complicated than that. Patents have, some good functions, and there are instances where patents are a good form of intellectual property to exercise, mostly by, big corporations trying to protect some already existing knowledge. But I do think that there are very concrete instances, particularly associated with technologies of global health and technologies of sustainability, where it's really a major obstacle, right? So let me give you an example. When I was 12, so when I was in 5th grade, I remember giving a presentation in my 5th grade class about the year 2000 and how solar panels were going to be everywhere, etc. Right? And so year 2000 came around, and of course they weren't anywhere. And so I did some research for a book I never wrote, which is just called "Dude, Where's My Solar Panel?" Right? Which is like, what happened? And what happened is that while there was a spike in research in the mid-1970s, it completely disappeared for about 26 years, right? Partly buried in patents, partly without any venture capital support. So there's a combination of factors, but I do think that one of the things that we can do is go around some of those obstacles with open source. It's not the only solution, but it's one of them. The other thing I didn't even mention at all, because I think it's maybe obvious, but I should mention it, is the educational aspects of open source. When I started being associated with the School of Information Science and Technology, I said, oh, well, how many classes are you teaching on Linux? And they're just like, no, we're not teaching any classes on Linux. And I said, well, why not? Because if it's open source, you can look at the code and you can see where the mistake is, right? Whereas if you're working with closed source code, you can sort of guess at what the conflict is or something like that. And that's just the beginning of the example. Connected to the interwebs, as we call it now, and using all the different technologies that we're starting to be able to hook up to it, the very practice of science is itself undergoing a transformation, right? Part of the interesting thing that can happen now is that we can have amateur science, quote unquote, like people who aren't located at big research institutions or working for big companies, doing breakthrough work in knowledge production, right? So there's a zoology, there's an astronomy project where they're mapping a galaxy, and the zoology of the galaxy, totally volunteer. Linux, obviously, a great example there. So it no longer has to be something that's confined to big research domains, but something that we can participate in our whole lives. In other words, we can be educated our whole lives instead of saying like, okay, I'm out of school now, I will go to work for this large faceless organization and tender unto it my intellectual property forever. Yes?
One thing happens educationally is that in open source, your likelihood of contributing to public body of knowledge is much, much higher than getting a patent on something you discovered, even if you do have the intellectual property rights. So that's one of the nice things about open source, because it's very hard. And contributing to the academic research body of knowledge, it's a PhD in a few years and a lot of funding and so forth. But that you can actually, and that's happening in this room. Kevin has contributed stuff that people have picked up, and
Awesome.
we have several other things I can see underway. So that's a really positive thing, to be engaging in something educationally, where you'll have a concrete, tangible, and you get a response from the community. So it says, oh, that's neat, I've just tried it, it works.
Yeah, and then it's that last bit too. I mean, it's meaningful work.
Yes.
You do it, and it makes a difference. It doesn't disappear into a void, right? It becomes part of the ongoing practice of knowledge. That is actually immortality, right? This idea of uploading yourself into the galactic webs is sort of like more of a nightmare. But actually contributing to something that can then live on, that people can take up into their projects, that's a very meaningful thing. That might not seem that important now, right? Because most of you are sort of in your 20s. But there's a certain point, sometimes you hit the ground running in your 20s, you start working on something, you're part of a couple of different kinds of projects that are very promising. And then you're in your mid-40s and, like, yes, you've been drawing a salary or whatever, what have you done? Most of it doesn't exist, right? So being able to contribute is really a meaningful part of being alive, yeah.
So you kind of gave like 2 examples, right? Like working for the Faceless Corporation or kind of contributing to I guess, the open source movement. Do you kind of see the balance of like where open source things come from? Do you kind of see that shifting in the future, or do you kind of see? I mean, because I think a lot of open source, at least in my mind, is kind of associated with people kind of working out of their garages or working after work.
Or at work with the window open while they're at the Faceless Corporation, right? I mean, somebody did an interesting study of all the IP addresses where people were making patches to the Linux kernel, and a lot of those people had other jobs, right? So it's not a total opposition, but I do think that yes, more and more knowledge and more value can start to come from the much lower overhead domains of people collaborating with each other locally and at a distance themselves, right? I mean, it starts to beg the question of why you need, a big faceless organization, right? So, for example, I'm a professor. Why do I need Penn State? I could just have flash mobs and show up, and if I'm talking about anything worth talking about and teaching people something, they're going to start showing up, right? And maybe then, and already actually, I put podcasts on the web, and I don't ask for money. In fact, I say I don't want any money, and people send me money sometimes. So then I take that money and I give it to other people who share their knowledge. But the point is this, brand, right? Brand is still a big deal. So that's what's going to be interesting to see how it happens, right? Like, there's a lot of things that I wouldn't get to go to if I didn't have that PSU letterhead. Right? So even if I could migrate my salary to this kind of more informal network, which I think is it's on the border of being doable now, then you still have domains where the publication network is driven by brand, right? Like, I thought it was important to publish a book on a university press because those things. So that's all going to shift. So what I'm just saying, hierarchies will remain, but I do think that they're going to flatten out considerably. And that's what's going to be really exciting, because all of a sudden we'll go from X, research scientists that we have working officially in the United States, not to mention the whole world, to 10X, if not more. All of a sudden we go, boom, we have all these people. Now, quick example of something that I'm working on that just shows the power of this. The writer Philip K. Dick, a science fiction novelist. I don't know if you've heard of him. He did the text that Blade Runner was based on, Total Recall, Minority Report. There's 8 films currently in production. And his books are great. They're unique. Most people who start reading them, they become a kind of addiction. They're very strange books that sort of take you over a little bit. He wrote, between 1974 and 1982, a 9,000, more or less, 9,000 page, mostly handwritten text, where he was basically trying to figure out the meaning of the universe, right? And who could read that? Right? It's handwritten. It's got all these references. This guy like has read everything in the world, right? Especially Encyclopedia Britannica, right? No individual could do that, right? But we link up with like 30 people. Eric was part of that. And we had, how long did we have? 6 months?
Something like that, yeah.
6 months to figure out which of the 9,000 pages should get published in a volume of 933 pages, which it came to, right? And in what order and what context. No individual could do that. But by doing what we call swarm scholarship, and we found out, of course, that people had already had that name, swarm scholarship, we were able to do it. And some of the people were fans, some of them were students places, some students here. And, you know, we helped out. There was still an editor. We helped them do that. So finding projects where you can leverage the collaboration of large numbers of people, some of whom have expertise in an area, some of whom don't necessarily, is going to be a way to generate value in the next 20 years, right? You got all these people ready to do something meaningful.
Sounds good. Any more questions from you guys? I really appreciate you coming in here. We mentioned the
Got
wiki
one.
to them.
Yeah. But yeah, we'll talk wiki in a minute if you like. Yeah.
At least recently, some European states and California were passing laws allowing you to establish sort of beneficial companies, I guess. I was wondering if you could say anything about that.
I had, but I wasn't able to get enough details to see, like, well, you know, how does that work? Because, you know, I knew that that's what Google thought that it was, right, for example. And it turns out that, you know, it just doesn't work to say don't be evil, right? You know, that there may be systemic constraints. I think it's a hard problem to solve, actually, to figure out how you can create some structure of governance besides an NGO or a 501c3 or a nonprofit that allows you to both get the benefits of a corporation, right, raising capital, limited liability, and so forth, without, you know, making them into persons that fund political campaigns. But Wiki, you wanted to.
Oh, just as I thought that the importance of part of the importance of having you here. You briefly mentioned then the importance of the wiki, but you really bring it all together a little bit better, I think, in terms of why it really is useful. Like, no, seriously, that NCU make mean something, and you know,
Just a
people
little.
do check that stuff out, just a little bit.
Yeah, I mean.
And then appreciate that wiki because it's not going to be accessible tomorrow, right? Isn't it
Oh, right.
blacking out for so
Is it tomorrow? Yeah.
tomorrow it's
Yeah.
blackout, so
It's a people blackout now. So was
Still
done,
banned.
but it was always meant to be done to get people through.
okay.
But remember, it wasn't very long ago, and remember, even Stephen Colbert, who was, of course, in certain ways a genius, was poo-pooing Wikipedia, right? Like, I don't know if your memory extends that long, but when Wikipedia was first coming out, and of course, it's the most successful knowledge production project since the Library of Alexandria, and you can't burn it down. That people were criticizing Wikipedia precisely because people like you and me can contribute to it. Well, anybody can contribute to it. It's like, yes, that is the strength of it. And the great line, of course, is from Linus Torvalds, the architect of Linux. He says, with 1,000 pairs of eyes, all bugs are shallow. Right? In other words, all problems can be solved by 1,000 pairs of eyes. So even Colbert, though, maybe it was only like 3 years ago now that he had his critique of truthiness, right, on Wikipedia, because it's hard for us culturally to accept that a group of people who don't know each other spread over the planet could do a better job than an expert. But that's the nature of collective intelligence, right? It's not true for all things, probably. You know, like I have a friend who's a painter, he's a really good painter. I doubt all of us together, working together, could produce a better painting than he would. But we could probably produce some interesting art. So, Wiki.
Good stuff.
Yeah.
Yeah, it's interesting how productive this sort of open source anarchistic type of collaboration is compared to when we get form a committee to study something.
Well, exactly. I mean, that's you know, that's another thing to remember here. That this class, you know, part of it comes because Dave was willing to go into his pocket and come up with $1,000 basically and say, I'm going to buy one, the parts for the first rep instead of taking forever to go through the grant that we had. But what's really interesting is that this has all happened without any direction, as it were, right? There's no top-down, like, there's no task force from the university saying, let us study how we can best introduce new emerging technologies into the curriculum.
Yeah, we select our speakers awfully carefully, and that we think long and hard before we have any presentations because of that.
Yeah, because what happens is that it just gets in the way. So, an anthropologist named Pierre Clastres, a French anthropologist in the 50s, there's a book, you can look it up, it's called Society Against the State. And he was studying tribes in South America, and he wanted to just study what did they do all day, right, And he figured out that they worked for basically, the men worked for like 2 hours, the women worked for like 4 hours, and the rest of the time they did what we would call some conglomeration of art and religion. And they're like, wow, okay, what happened, right? How come we don't do that? How come we work 8 hours a day instead of plus, and so forth? Well, what he was studying is that every now and then there would be a war, and the wars were completely highly choreographed. They were like somewhere between dance and theater and a brawl, right? Of course, they didn't have any high-tech weapons, so but he wanted to know what were they waging war for. And what he figured out was that they were waging war against committees, right? Like, it's called Society Against the State. That what would happen is that the society would get successful enough, right? There was enough food, people were agreeing about their art and their religion and everything. Everything was pretty copacetic, and so forth. And then somebody would want to organize it. It's like, hey, let's make this permanent. Like, let's make this the religion that we hold on. And that the wars were a function to disrupt that periodically. So the other anthropologists had assumed that all societies tend to evolve eventually a state, right? That is the highest form because it's more organized, right? How can you get anything done without having lots of organization from the top? How would anybody know what to do without, a board of trustees to tell them what to do? But in fact, it's the exact opposite. That what he found anthropologically is that all of these groups that act like they're running things are sort of parasites on top of the actual creativity of society that take credit for the creativity.
Call it administration.
But exactly, and that would call them administrators. But they don't actually do anything. I've been trying to figure out, is this part on the tape? I've been trying to figure out what they're doing. I don't understand.
Well, they create work for us and obstacles for us. What they do, they lower productivity. That's just nothing like.
In order to justify their jobs, and what they do is they hire more of themselves.
Yes, absolutely. They do produce. Absolutely.
So, just think about that. So in other words, a lot of times we think oh no, what happens if we don't have any direction from the top down? Somebody's got to be the boss, right? It's no, actually, in a lot of situations, there are some situations where that's necessary. Like if you're on a submarine, right? You want to know who else is going to turn the key when you're doing a nuclear launch. But, otherwise, in fact, it's highly overrated that nature works from the bottom up almost entirely, right? Evolution doesn't have a central command structure. It's okay, can we develop the platypus now? Right? We've got an idea. We're going to put a bill on this egg-laying, milk-yielding thing. Is that cleared with headquarters? Over. It's just it doesn't happen like that, right? Whereas human beings, we think that's a habit of thought that we have.
All you need is a swamp.
All you need is a swamp. All right, I need to go check my son's.
Thank you. Good job.